Hello friends, welcome to Chemistry Nuggets where you can polish your knowledge and clear your doubts. So friends, today's video is about Mesomeric effect or we can say resonance effect. This effect we have already learned in the previous video about inductive effect. This is the continuation of that. So next coming is Mesomeric effect. So, same story when a reaction starts, a substrate turns to the product. Now this substrate is going to intermediate condition where a reagent attacks. So this reagent attacks at which point or at which place of the compound. Compound is not a one point thing, it's a long chain of carbon. So at which carbon the nucleophile attack and at which carbon the electrophile attack. The whole story is depend upon the inductive effect and mesomeric effect. So let's start the Mesomeric effect. But before starting the video, if you haven't subscribed the channel, please subscribe it and press the bell icon so that you can get the notification for the next coming videos. So friends, let's see the definition first. When the polarity produced in a molecule as a result of interaction between two pi bonds or a pi and a lone pair of electron is called as mesomeric effect. So suppose we have a compound having a one in which one atom is more electronegative than the carbon. So what simply is going on there? The electronegative atom will attract the lone pair of the electronegative atom will attract the lone. What will happen? The electronegative atom in that compound will attract the shared pair of electron towards itself and it will make the whole compound polarized. So this whole process, when it goes through with the help of pi electrons, this is called mesomeric effect. So suppose we have a carbonyl group, C double bond O. This is our carbonyl group. So in this, oxygen is more electronegative than carbon. So there are two bonds, one is sigma and one is pi. When the pi electrons of the electronegative compound attracts toward the electronegative atom, what will happen? This will become negative charge having two electrons of the shared pair and the carbon in turn become positively charged. So this is called mesomeric effect. This mesomeric effect is of most important when there is a conjugated system. That means when there is a compound which is having alternate double single bonds. Let's have an example. CH. Sorry. This is CH2. So this is our compound, suppose. So what is going on here? Here it is a pi bond and this is attracted by the oxygen. This in turn, what will give? If this oxygen is attracting the pi electron, in turn carbon will turn positively charged. So for balancing that, this pi bond in turn shifted to this. And again this pi bond shifted to this condition. So what the new compound which is formed is something like that. CH2 single bond, CH double bond, CH single bond, CH double bond, CO, and this is minus and the plus charge will be shifted to this position. Now see carefully. Earlier when there was shifting, the oxygen will be negative charge and next the carbon will have the positive charge. But for balancing that positive charge on that carbon, the next coming double pi electrons, or we can say the double bond, are giving their electrons towards the carbon and shifting the positive charge to the next level. This kind of shifting of electrons of pi bond is called as resonance effect, and these two compounds, number 1 and number 2, are the resonance structure of each other. Now, in this case, this is a permanent type of effect. Mesomeric effect is a permanent effect. That means it doesn't need any reagent to go through this type of interchange. In a neutral inert condition, this will be interchanging itself and they will make the resonance structure. So when this condition is already done, now in the intermediate condition, when reagent is there, if a nucleophile comes, where it will go to attack, it will jump directly to this carbon. And if electrophile is coming, where it will go, it will directly jump to this negative charge. So this will happen, and this is the need of understanding mesomeric effect. So where should we attach nucleophile and where should we attach electrophile? So this is all about mesomeric. Let's have a look on the important points. First point is it involves the pi electrons of double and triple bonds only. It will never go through the sigma electrons. Sigma electrons are involved, that means it is a inductive effect. Second point, it has a great importance in the conjugated system. As I told you, conjugated system has more importance in the resonance effect. Third point, atom which loses electrons towards the carbon atom have a plus M effect, and atoms or groups which draws electrons away from the carbon atom have a minus M effect. So like inductive effect, here also mesomeric effect is of two types, plus M effect and minus M effect. So when there is a transfer of electrons from the atom towards the conjugated system, this is called plus M effect, or the group which is doing this is called having a plus M effect. And then there is a transfer of electrons towards the conjugated system. Sorry. If the effect is observed when the transfer of electron is towards the atom from the conjugated system, then we can say the atom has the minus M effect. Okay. And next point, as I already told, it is a permanent type of effect. It doesn't require any reagent to behave polarized. Now, come up to the point, we will study plus M and plus minus effect. First of all, plus M effect, or we can say it is plus R effect. Let's have an example of aniline. Aniline is having a structure of NH2 or having a lone pair of electron, and it will be like this, this and this. So this is our aniline. What is going on here? This lone pair of electron attacks here, so that this also shifted to this place. Now what is the new resonance structure is like that. This will turn to double bond because one bond is already here and one bond is coming, NH2. Okay, and this will having a plus charge because electron is shifting away from nitrogen. Now, what is going on here? Here, the minus charge is localized here, and here one bond and here one bond. Now, in the next structure, what is going on? This in turn jump to here and this in turn jump to here. So we will get our next structure in which NH2 having plus charge and excuse me, it is having here, one here, and minor charge will be here. This in turn again will jump to this place, and this bond jumps to here. The next resonance structure will be like this, in which one bond is here, negative charge will be here, NH2 is as such having plus charge, and one bond is here. So these four structures are known as the resonance structure of aniline. And this is showing the delocalization of electron due to the plus M effect. Now let's have a look on minus M effect, also known as minus R effect. So don't get confused if you are getting anywhere minus R or plus R, and you will tell, oh, I learned the plus M. The best example to understand minus M effect is nitrogen. This is having a structure like this, N O O, and like this, NO2. So what is going on here? In the minus I effect, the shifting of electrons from the conjugated system towards the substituted atom or group. So here the electron shifting is like that. This electron shift here, and this bond pi bond shift here. Now what will happen next is we will have a structure like this, same structure but different positions of pi bond. Here N O, here O having a minus charge because electrons reached the minus oxygen, so it having a minus charge, and now plus charge is located here, and rest of the bonds are same. Now in this condition, what will going on here? This pi bond jump to this plus position, and in turn what will happen? Again bond is here and plus charge will reach here. Again, to delocalize this plus charge, this bond will shift to this place. Now what will happen? The plus charge again having a new place, bond is here, and now plus charge is shifting to this place, and rest all the things are same. So we can say that the plus charge is shifting alternatively and they have a particular place to be shifting. They will not shift anywhere. They have a particular place to shift. So nucleophile will attack on a particular point of the compound. It will not attack any point. And this point is determined only by the mesomeric effect, or we can say in other systems it is inductive effect. So this is all the story about mesomeric effect. Hope you guys understand. If you have any doubt, you can write a comment in a comment section. I will surely look at that problem and try to solve that. Till then, thank you.